Greetings, everyone. My name is Ben McLeish, and I am a product solutions manager for Dimensions. And together with Leah Lipitakis, we're going to show you how you can empower your institution's search, discovery, and analytics using unique AI technology supporting your entire research lifecycle. Up until very recently, academic institutions have answered most performance, impact, and collaboration-based questions with publication and citation data. Publications occur after research concludes, and citations happen years later in most cases. Dimensions indexes and interconnects global grants data, millions of preprints, data sets, publications, online mentions, and academic citations, all global patent data, clinical trials, and 750,000 policy documents. All in all, there are 270 million documents, 85% of which are indexed in full text, citing each other nearly 5 billion times. Institutions can now anticipate new research trends by analyzing what research is currently being conducted years or even decades ahead of publication, as well as downstream reuse in policy, patent literature, and clinical trials. All in all, Dimensions has indexed over 120 million publications, around 50 million more than current ANI databases tend to. Additionally, we have indexed nearly 9 million data sets, over $2 trillion in grants, the world's 138 million patents, and 650,000 clinical trials. In total, over 270 million documents can be found, searched, and analyzed within the Dimensions system. All content is then connected where it cites other content and classified by artificial intelligence and assigned to such classification systems as the UN Sustainable Development Goals, NIH classifications, or fields of research. Dimensions also affiliates all content to the institution as well as to the researcher. As Dimensions classifies each item based on the content rather than the journal classification, it's also possible to search the system by keyword as well as by a set of concepts or even categories. Records are connected to their related items in Dimensions. In addition to standard metadata like abstracts and publication details, Dimensions recognizes and surfaces acknowledgement sections from publications. Through machine learning, we recognize funder names and specific grant IDs. Dimensions AI categorizes each patent, clinical trial, grant, or publication based on processing each abstract. In this slide, note down this bit of information if you're playing the Riddle Me This treasure competition. This is the Dimensions homepage view. To the left, you can use the filters to start refining your search, and to the right, you can start analyzing your results. We're now at the publication view, where you can see 120 million records, which you can view, drill down to the article level, as well as sort them in many ways. We have sorted these results by the highest altmetric score. At a glance, we can view how many citations they have received alongside advanced normalized citation metrics, such as the field citation ratio or the relative citation ratio, or their altmetric impact, showing the attention surrounding your institution's research, for example, if they have been referenced in policy documents, news, or patents. You can navigate seamlessly to get from publications to data sets and grants, and from patents to clinical trials and policy documents, all in one place. And for each output type, you can refine and analyze using relevant filters and metadata. For example, when searching for grants, you can select the period which they have started or that they are active in, or grants awarded by a particular funder or received by your institution, or sort the grants by the highest amounts of funding within the research area of interest. In this part of our presentation, we'll show you how you can discover and analyze research in the context of the United Nations Sustainable Development Goals.
In Dimensions, there are more than 6 million publications, 150,000 datasets, and 500,000 awarded grants that you can link to Sustainable Development Goals output. You can analyze this SDG output with a focus to a specific research area of excellence or understand the multidisciplinarity of your SDG outcomes. Or you can analyze your institution's SDG to track broader research output and impact towards achieving your goals. Let's look at this article about the effectiveness of a vaccine in preventing Ebola virus. It is a multi-author collaboration between various policy organizations and academic institutions, amongst them University of Cape Town. We can clearly see the wider areas in which this article is contributing using various classification schemas, the broader fields of health, but also more specifically in biodefense, infectious diseases, and immunization, with a focus to vaccines and pharmaceutical research. It is also classed as Sustainable Development Goal 3, Good Health and Well-being Outcome, for research that has been funded by European Commission and Wellcome Trust, amongst others. Here we can see an example of the broader academic and socioeconomic impact indicators you can find in dimensions at the article level. You can keep track and report upon your progress towards achieving and supporting these goals, and analyze those publications that can be linked to your Sustainable Development Goals agenda and provide evidence of your SDGs' societal and economic impact. This publication, which has been linked as output of SDG 3, has a substantial academic impact and has been used in policy documents published by the World Health Organization and National Academies Press, and used towards an invention and cited by the patent. You can drill down to the awarded grants that supported this SDG publication to get more information around the funding landscape of this research. The most recent of the awarded grants that has supported this publication is entitled Methods for Evaluating Vaccine Efficacy, and the funding amount was just over $5 million between 1992 and 2021. And this grant has supported 78 publications that have resulted from this grant. You can also see similar grants to these, some of which can be very recent or haven't even started yet, to keep track of the present funding landscape and anticipate tomorrow's research. In the next part of our presentation, we will see how we can discover and analyze an institution's Sustainable Development Goals output. For this analysis, we would like to understand the impact of Sdg's output in the entire South African region, and particularly view my institution's activity. So the first thing that I would like to focus on is understanding the entire output of my institution. And let's say my institution is University of Pretoria. In this view, I can see the multiple outputs of my organizations, more specifically 39,000 publications, 2,500 research data sets, more than 20,000 awarded grants, patents, clinical trials, even policy documents, all in one view. If we combine the SDGs view with a view of my institution, I will see that Pretoria has more than 5,000 publications that are linked to an SDG, 140 research data sets, and 1,200 grants supporting SDG outputs. If we focus in a more recent time window, let's say the past 5 years, we will see that 20% of Pretoria's publications are linked to an SDG outcome. I want to know more about them, so let's analyze those SDG publications. First, I would like to see my institution's publications per SDG. You can analyze your output by a number of multidisciplinary research classification, ranging in terms of focus and granularity, implemented by dimensions. Here we'll select this SDG classification. I can see that the number of publications alongside the number of citations that they have received and the average citations per SDG publication. Dimensions offers a wide range of academic and social indicators for volume, impact, and category and attention, such as the field citation ratio, the relative citation ratio, and the altmetric attention score. We know that SDGs can be quite multifaceted and have impact in various areas of research. So it would be very interesting to see how multidisciplinary my organization's SDG publications are, how diverse they can be in terms of the fields of research they represent, and what is their impact using the heat map visualization. In the heat map visualization, the rows show my institution SDG publications broken down by fields of research as shown in the columns. I can see that the majority of SDG 3 good health and well-being publications focus on medical and health sciences, public health and health services, biological sciences, and to a certain extent, agricultural and veterinary sciences. Whereas SDG 7, affordable and clean energy publications, are more focused on the field of engineering with certain publications in economics. In the next section, we will see how we can benchmark SDG output at the national level or with other peer institutions. First, I would like to benchmark my institution's SDG publications at the national level and with other South African organizations to understand their impact in my region. For that, I will limit my time period to recent SDG publications between 2016 and 2019, and I will analyze the volume and impact in the corresponding field using the field citation ratio indicator. The top 3 SDG areas for my institution are SDG 3, 7, and 13, in which I see the highest productivity combined with performances higher than the global average when compared in the same field of research, publication date, and document type, ranging from 2.5 to almost 3 times better. Next, I will analyze all South African publication in the same SDGs as before to benchmark my performance in terms of field citation ratio indicator. For the same time period, there are in total more than 6,000 South African publications linked to SDGs 3, good health and well-being, more than 3,000 publications in SDG 7, affordable and clean energy, and just over 2,000 publications in SDG 13, climate action. In all these 3 SDGs, South African research demonstrates very good performances above the world average in the same field of research, publication date, and document type. I can now benchmark to see what is the share of my institution's contribution, like we saw in the previous slide, in terms of volume of national output in those SDGs. I also see that in SDG 3, good health and well-being, my institution's performance is in line with the national performance, while for SDG 7, affordable and clean energy, and SDG 13, climate action, my institution's performance is driving national excellence, exceeding the national averages. At any point of time during my analysis, I can benchmark side by side 2 institutions or funders in terms of publication trends in any of the dimensions classification schemas using the compare analytical view. Here, I see a comparison between the SDGs publications of University of Wits and University of Cape Town for the past 5 years. You can learn more about how dimensions can support your SDG reporting by watching our on-demand webinar, and you can download our report, Contextualizing Sustainable Development Research. For the last part of our presentation, we will show you how you can use advanced artificial intelligence technology supported by dimensions to define your topical searches and identify the most important international funding sources to strengthen collaboration opportunities using grant and funding amount information, not just text coming from funding acknowledgements. Let's use an area which is very important and priority topic, sexual and reproductive health. And it is an area of excellence for many South African institutions and has applications focused on research, technical assistance, advocacy, policy development, and health system strengthening. A very important aspect of analyzing output and impact is the way that a data set is defined. In dimensions, there are unique ways and tools to search, discover, and define search queries using cutting-edge technology that traditional databases do not offer. In dimensions, when you search for a topic, you can enter keywords and use the advanced search. In the advanced search, you can use co-occurring concepts to better define and augment your search. How do co-occurring concepts work? Dimensions advanced search allows you to build a more complex search by asking dimensions to suggest terms and concepts co-occurring with the keywords you're looking for using the publication and grants network. In a traditional database, this query creation process would be performed manually, and in most cases, researchers would have to use external resources and put a lot of effort and time. Dimensions uses advanced AI and machine learning technologies to extract relevant nouns and phrases found in the titles and abstracts of publications and awarded grants, where the relevance is defined by the field of research the text talks about. For any of your research, you can select the advanced search, to automatically add co-occurring concepts and relevant terms using natural language processing technology to further define, augment, and complete your search with saving incredible amounts of time and effort. Now, a traditional database would execute this search using a simple search for keywords in the title and abstract fields of the publications they index. In Dimensions, you would still find more content using just the title and abstract search, as Dimensions indexes almost double the publications compared to a traditional database. What is unique about Dimensions is the full text search that allows you to discover relevant publications that you would miss with just a title and abstract search. For this topic, we have discovered 10 times more publications, 3 times more clinical trials, 20 times more patents content, and 25 times more policy documents. At this point, I would like to see how South African research ranks in terms of publications volume in this topic. South Africa ranks 7th in terms of publication output in the world. I can see which South African institutions have produced these publications and further analyze their socioeconomic impact. Wits University, followed by University of Cape Town and University of KwaZulu-Natal, are amongst the top 3 South African institutions. As we saw, sexual and reproductive health topic has important social policy development application. And at this point, I can continue my analysis by viewing, for example, which policy documents and policymakers are using this research. The World Health Organization has published 15,000 policy documents, followed by the government of the UK and Centers for Disease Control and Prevention that have published more than 1,000 policy documents, referencing publications you have discovered using the unique full text search in Dimensions. Last but not least, I want to analyze the funding landscape in this research area to discover which are the most important global funding sources and awarded grants to help me identify potential funding sources for my institution's researchers. I can see there are almost 3,500 grants awarded in this area. I can use the start year filters to focus on my attention on the grants that have started in the past 5 years. I can see almost 1,000 awarded grants that have started since 2016. Next, I would like to see which funders have awarded these grants. If I rank by funding amount, I can see that Bill and Melinda Gates Foundation has awarded grants in the range of $79 million, followed by Eunice Kennedy National Institute and Hewlett Foundation. Also, we see grants. The UK Medical Research Council with $30 million worth of funding. If we sort by highest number of grants, we will see Eunice Kennedy National Institute at the top with 115 awarded grants, followed by the Canadian Institutes of Health Research with 74 grants, and the National Natural Science Foundation of China with 67 awarded grants. At any point during my analysis, I can drill down to the actual grants or funders profile. So let's go and see the Medical Research Council's grants. Here, you can see all the grants awarded by Medical Research Council in our research topic that have started since 2016 with funding period and funding amount information. I can drill down to the actual grants to see the full information. Here I can see how the principal and co-investigators are, and the research organization, both from Stellenbosch University in this case, the different research classifications that the grant has been classified into, and you can search by. For this grant, we can see the reproduction health and childbirth category, which is in line with our original search about reproductive health, or view similar grants awarded by other funders. Lastly, we can analyze the awarded grants by researchers and identify potential international collaborators to help make inroads with global funders and strengthen our funding applications. Thank you for your time. I hope you found this useful and we will be delighted to talk to you more in our Dimensions virtual booth, or feel free to send us an email. Bye-bye.
Hi, I'm Elizabeth Leonard, the Associate Director of Research and Development at AAAS Science. I'm joining you from Washington, D.C., and my colleague, Dr. Lee, is joining from the UK. While this session is recorded, we hope to continue a conversation with you at the booth, via Twitter or email, and of course, next year in person. Without further ado, please allow me to introduce our speaker. Dr. Michael Lee is the editor of Science Robotics. Before becoming an editor, he conducted research at the Paul Scherrer Institute and at the University of Oxford. Mike?
Thanks, Elizabeth. I'm really excited today to talk to you all about robotics. So if I was there in person, I would usually ask these three questions. The first question would be by way of raising a hand, who owns a robot? Generally, a few hands would go up. I would pick on a couple of those people who put their hands up and ask them, what does the robot do? And generally, they would say it's a cleaning robot, a robot that vacuums your floor, right? The next question I'd ask is, well, is it any good at what it's meant to do? Varying answers, but it all sort of converges onto one response, and that's kind of. So why are robot vacuum cleaners, why do they kind of work? Well, they get trapped between furniture, they have appetite for loose cables, and they're not that comprehensive in their coverage. And one kind of funny comment I got was that it moves my furniture around, a kind of robot feng shui, if you will. How do we solve these problems? Well, we move the furniture. We can tidy up the floor, move any cables or loose items. So we can ensure the floor is clear, that the robot can access all these areas, and you can weigh down any furniture that you don't want moving around. Clearly, this isn't an ideal case. I do it on a daily basis to kind of run my robot. But we don't want to design our environments, our home, for robots, right? We want to be able to work anywhere. And herein lies the problem. It's all about the environment. The household is not an ideal environment, in so much that it's unstructured, which is the polite term for messy, right? And I think really it's the point I want to kind of get across in this talk is that the majority of robots we see today operate in structured environments, focused on well-defined tasks. An example I often give are industrial robots, robots in cages, and these robots here are building the cars that we use and drive. So really the goal is to set robots free, okay? For robots to be truly useful, we want them to operate in unstructured environments and often with high levels of autonomy. We don't want to be there to intervene. We want to get on with the task that we've set them. So how do we make better robots? First of all, robots need better information, and they get it through sensors and a variety of different sensing modalities. Once they have that information, they need to be able to process it and make smart decisions. So we need developments in software, artificial intelligence, and better computing platforms to execute these programs. So once a robot knows what to do, how does it do it? Well, it needs developments in electromechanical engineering and actuators to achieve locomotion in clever ways to create robots that are agile and maneuverable. And often we need all of these developments to come together. As engineers, we talk about the full stack solutions, the different layers of the solution. You need devices, components, and systems to all come together. And within those kind of approaches and those areas of research, you need advances from basic material science, from computer science, systems engineering. Robotics is really an interdisciplinary research field. So if we achieve all those goals, what does that mean for your robot vacuum cleaner? Well, it means it'll have better robot path planning. It'll know how to cover the floors more comprehensively. It'll know where to avoid certain traps. It'll learn from its mistakes, and it'll be able to recognize furniture and keep it where it is. And related to that, the robot should be able to detect objects. It should know what a loose cable is, what a loose item is, and be able to avoid those, right? And finally, if it does get stuck in any way, it should have the ability to maneuver itself out of those kind of tricky situations. So I spoke a lot about the robots that exist today and very much how bad robot vacuum cleaners are. That's not what we're focused on at Science Robotics. What we're most excited about is the robots of the future. What will they look like? So that's what I'm going to share now. This is a soft robot, so a robot made of soft materials going through some pretty tricky environments. Here's some sticky paper. So these are environments which conventional robots may struggle with. And what these soft robots do is really leverage the ability of their material properties to get through all these kind of tricky environments. And this is a mission for the robot. Let's say it's delivering a sensor for some tricky situations. This really illustrates what one benefit of soft robots, the ability to get through these really tight gaps where you think a conventional robot would really struggle to do that. And one of the great things about soft robots is the simplicity of design and the versatility of the different areas it can locomote and move in. We're also excited about robots which may not even be used on Earth. So for example, this is like a prototype of a Mars rover solving the problem of how do we get out of a kind of wet granular material such as wet sand. The trick here is not just to use your wheels and spin them, it's to use your legs and move your legs around to agitate this wet sand. You can see this a lot better in the next clip. And we're hoping these developments will end up being used in our future kind of Mars rovers for planetary exploration. In the same vein of legged robots, this is a robot I quite like, these quadruped robots or dog robots, and it's doing a really tricky thing here, and it's moving over a wet surface, which if you're a human is difficult, right? Let alone a machine, and it does this using a machine learning inspired controller, to be specific, a deep reinforcement learning to achieve locomotion in this very tricky environment. So you'll see in the next clip the robot moving without the controller, and you can see how it struggles. So straight off you can see that it slipped in its back leg and it's supported by cable, so it's not doing very well there at all. So that's what we're excited about as well, kind of combining developments in artificial intelligence with robotics. Another area we're excited about is Undersea Robots. This is a robot which is inspired by the natural world. It's a robot fish, which is designed to move and look like a real fish. The idea here is that we can develop these robots which can study these ecosystems, such as like the Great Barrier Reef, without disturbing the fish and other things surrounding it. In the bottom left, you'll see the video or the shot of the robot, and this is what the robot sees. And you can imagine that this would be deployed in many different scenarios, and we can get a better sense of what the ecology is and try to kind of learn from these missions. The next clip I'm going to show you is drones being used in the Antarctica, and this is a real. Next one's a real field mission where there should be real outcomes. All right, thank you for your attention.